Call is now being recorded.
All right, we are going to go over Module 5 today, looking at graphing quadratics, and we're going to use our graphing calculators. So again, you can either use your own graphing calculator or you can pull up desmos.com/calculator and use that. So remember that the axis of symmetry is a vertical line that divides a parabola in half, and the vertex is the highest or lowest point on the graph depending on which direction the parabola opens. So our zeros or x-intercepts are where we cross the x-axis, and the y-intercept is where the graph crosses the y-axis. So we've got two forms for our quadratics. We can either have standard form, which is that ax squared plus bx plus c. And if we want to find the axis of symmetry, we're going to use the formula x is equal to negative or opposite b over 2a. And if I want to find the vertex, I will take that same x value, negative b over 2a. And then if I want the y coordinate, I'm going to plug in that axis of symmetry value. And that is going to give us our vertex in standard form. In vertex form, remember our vertex and axis of symmetry are both given. So our axis of symmetry is going to be at x equals h. And then our vertex is going to be at hk. Remembering that your h value is the opposite of what is in the equation. So if I want to find the axis of symmetry and vertex for each quadratic here, I'm going to take this one in standard form. So I need negative b. So I've got negative 18 over 2 times negative 6. So that's negative 18 over negative 12, which will give us 1.5. And now I can go ahead and plug 1.5 into our function and figure out the rest of our vertex. Once we plug that in, we get out 28.5. So our vertex is the point 1.5 and then 28.5. Our axis of symmetry is going to be x equals negative 4. And then the vertex is going to be the point negative 4, negative 5. So it is, of course, quicker to find vertex using the vertex form. So the rest of these are now we're going to be graphed. So again, you can either go to desmos.com/calculator or you can use your TI-84. So first thing I'm going to do is graph that function. So once we have it graphed, this is why Desmos is a little bit easier. If you want to find the vertex, you can actually just click on that point. And we have the point negative 4, negative 12, which of course we know because it is in vertex form, which means our axis of symmetry is also at x equals negative 4. Y-intercept, we are looking at where we cross the y-axis. So I can kind of zoom out on this. And then once I find where it crosses, Desmos gives it to you. So you can click on the point and it is 0.36. So for my zeros, again, I can click on it using Desmos. So I have a 0 at negative 6 and negative 2. So now this is also where Desmos is really handy. If I want f of negative 3, that means I'm plugging in 3 for x. So if I go to Desmos and do f of negative 3, it will give me out the value right away. So it would just be negative 9. And then this one is saying for what values of x is f of x equal to 10. So remember, f of x just really means y equals 10. And what's cool here is if I graph y equals 10, I want to figure out where I hit my graph. So I hit it twice. So I hit it once at about x equals negative 1.3. And then I hit it again at x is equal to negative 6.7. For our application problem, we are given this equation. So the first thing we're going to do is graph it. And instead of using t for the variable, once you plug it into the calculator, we're going to just go ahead and use x. So once we have it graphed, we're going to go ahead and answer the questions here. So first, I want to know how long does it take for the object to hit the ground? So this is referring to the x-intercepts where the height is 0. So I can go ahead and click on those points and we'll approximate them. So one of our zeros is negative, and when we're talking about time, it doesn't make sense to have a negative time. So we actually only have one answer here, and it would be 5.9, and then this would be in seconds. Okay, if I want to find the maximum height, we are looking for the vertex. So I can go ahead, click on the maximum height there, and we're looking for the y coordinate, which is about 77.4, and then we are in meters for height. If I want to know how long it takes for the object to reach its maximum, we are still looking for the vertex, but we are looking for the x value of that vertex. So that x value is about 1.9. So it takes about 1.9 seconds to reach that maximum height. I want to know how high off the ground is the object in 3 seconds. This is our time. So that is what we are going to plug in for t. So in decimals, I can say I want s of 3, and then it's going to give me out that y value, which is 72, and that is 72 meters. And then finally, I want to know at what time is the object 25 feet above the ground. So again, this is looking at the y value equals to 25. So I can go and graph the line y equals 25, and then it crosses at 2 different points. But again, one of them is negative, so I don't want that answer. So I would say at about 5.2 seconds.